Next topic, indexes. See, every cube you create, okay, or ODS, every cube you create, it will have a primary index. Primary index is a primary key, so it will have a primary index. Apart from the primary index, if you can build secondary indexes, it can improve your query performance. General index is like index page of a book. Obviously, it helps you to find the corresponding page. So when you build indexes on the cube, it will speed up my query performance. And the index what you are creating is a secondary index. And when you start creating a, because for each dimension of a cube, it creates one index. Okay. And when you just say create secondary index, it does create bitmap or B-tree. Rendu chances on it. Let's say my cube has got 5 dimensions. It will create 5 indexes representing for each dimension, and it can create B-tree or bitmap depending on the case. Now look at this B-tree, and it goes like this. You'll have a parent with 2 children, right child and left child. And always right child is always greater than the parent, okay, and left child is less than the parent. Let's have got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, okay. The tree ಎಲ್ಲ stories until let's say it puts 6 at the top and 7 to the right. Right child only greater than 6, left only it will be less than 5. At one comparison, I am reducing half of the probability. I am nearing to the half of the probability, the concept. Okay. Other bitmap, basically with the help of bits, it formulates your indexes with 1s and 0s, that is bitmap indexes. Okay. Now, can we control whether it has to create bitmap index or B-tree index on a cube, on a dimension of a cube? Yes. Look at this. So let's say I take some cube, okay. I want to build indexes on this cube. If you go to the change of it, set dimension. If you go to properties of the dimension, there is checkbox high cardinality. If you select this high cardinality checkbox, for this dimension it creates B-tree index. If you don't select saying high cardinality, when the values of the dimension is huge, number of dimension, size of the table is big, and when you enable it, it is going to create B-tree index plus. If you don't select this, it is going to create a bitmap index plus. That's how it is. So this checkbox high cardinality, you're indicating that the values in the dimension table will be huge when compared to fact table. So you won't derive, it is going to create whether bitmap or B-tree is determined based on this checkbox. Select just say B-tree, saying that high cardinality, so B-tree, because B-tree is faster when the values are more, okay, and bitmap is faster when the values are less, cardinality is less. So if you don't select bitmap, if you select B-tree, okay. So I've got one dimension with enabled, so it should be B-tree, and dimension 2 should be bitmap. Now how to build indexes now? Go to manage. There is a tab, what is this? Performance. There's 2, you can create index from the foreground, but I prefer it background. Create index, what is it? Delete index. Now create index, DB, selection. When do you want? Immediate. Start. Okay, apply. Now, if you say check DB static, it says what? Green. Now I want delete index now. Delete index, select.
Delete index on
all the dimensions. Check DB not becomes red. It means index has been deleted. Like this, you can create index or you can delete index, but in the real system, you don't do it manually. You'll be scheduling it in the process chain. And the point here to be noted is, if you create indexes on the cube, it improves query performance, but it degrades your loading performance, because every time on a page, if I give a book and I give some papers to attach, if there is no page numbers, you'll put it at the back. But if there are page numbers, you have to insert at the respective page number, so it takes a lot of time. So when you have indexes built on a cube, it takes a lot of time to load. So what they do in the real time, they create indexes for improving query performance, but every time they're loading, they drop, load and recreate. They assume that you do in the loading in the night when the users are not there. So you will drop indexes, you do the loading part and then recreate the indexes back, and the query performance is already fine. So you're able to handle both.
But will create in
extra it needs extra activity. అందుకే ఏమిటంటే బట్ ఇఫ్ యూర్ లోడింగ్ 1 record 2 records, don't do that. If you're loading sufficient amount of record, that makes sense for, but in real time it's a practice. Every time they load, they'll be dropping indexes, they'll be loading and creating indexes, okay, to handle the performance. And by default every queue will have a primary index, second index is bitmap and btree, and we can see those indexes also. This is my cube, right? I can see those index. Only create this. And index data kanapadadu gaani you can see the index being defined for it. Unless you can go to SC11 and see, or SC14 also. Okay, look at this. You can just see those indexes which is created on here. Actually, but actually, mundu old version it could have shown like B tree and a chupistunadu. You can just find out what type of index, but you cannot literally see the index is formulated. Data chullam. But only thing you can see whether index are created here, right? Now, if I say delete index, what is it? Only the primary index. Yeah, Ejemplo. No, all the indexes are deleted, of course. Like this, you basically deal with indexing and the concept. What I want to actually what they say is, okay, how do you identify whether this dimension table is going to be huge or not? Criteria that if the dimension table size is more than 20% of the fact table, I say high cardinality, let it create B tree. If it is less than 20%, I can go with what? Bitmap, as the concept. But there is a function model to run this and give you, but I'll show you in the next different topic. Kane, you'll get to see this count only after the data loading. So this program will not really help you to do this. So what we do is, at the designing phase itself, you'll understand, you'll find some dimensions with huge cardinality, like say dimension which is assigned with sales order numbers. You're loading sales order data into the cube, and the dimension with sales order number is huge. And if I load 1000 sales orders, my dimension table also will have 1000 records. Is it my size almost equivalent? So for those kind of dimensions, you will say high cardinality, which will create what? B tree indexes. And the function would what?